So I'm going to show you how to eliminate x. We have to do it twice, but I'm going to give you all three ways that you could possibly eliminate it. So first I'm going to go row 1 minus row 2. So row 1 stays the same, and row 2 is going to have all opposite signs. So when we add these guys together, we get negative 3y plus 4z equals negative 2. Using row 1, we could also add that to row 3. And this is nice because we don't have to multiply. So I'm going to go ahead and add x plus negative x cancels. 2y plus y is 3y. Z minus 3z is minus 2z. And then 4 plus 0 is 4. And then the only other combination we could do is row 2 and row 3, which we can also just outright add. So then the x's cancel. 5y plus y is 6y. Negative 3 is minus 6z, and then equals 6. All right, so we have three equations here, but again, we only needed to eliminate that twice. So most of you are probably going to do the row 1 and row 3 and the row 2 and row 3, these two. Since I already have this, I'm going to finish the problem just using these two linear equations. So we have negative 3y plus 4z equals negative 2, and 3y minus 2z equals 4. And I can go ahead and eliminate the y's. So I get positive 2z equals positive 2. So z is 1. Okay, now before I come back over here, I still need to solve the system. So I have z is 1. If I plug that in here, I get 3y minus 2 times 1 equals 4. I'm going to add 2. So 3y equals 6, which means y is 2. And now I can come back and solve for x. I'm going to use row 1. And when I do that, I get x plus 2 times 2 plus 1 equals 4. And this is 4 plus 1 is 5. So if I subtract 5 from both sides, then I'm going to get x equals negative 1. So I have z, I have y, I have x. So my final answer is negative 1, 2, positive 1.